It's only 48 hours, right? Good morning. Here we go. Let's get to, here we go. Here's our objectives for today. Hopefully we get through them all. If we don't, that's okay. So here we're going to try to determine what the domain is of a rational equation. And I think we kind of did some of this already, right? What can't you have in a rational equation? A denominator of 0. Then we're going to try to solve the irrational equations, recognize the graph of a rational function, and solve relational equations with graphing calculator. If we don't get to 4, that's going to be okay. So at least 1, 2, and 3 today. Alright, let's do it. Rational equation is the equation that contains at least one rational expression with a variable in the denominator. So, determining the domain of a variable in the rational equation over the denominator, something like this. Okay? So, we have 3 over x plus 1 over 4 is equal to 9 over 4x. We remember, we can't have the denominator be equal to 0 because that would just make it not irrational. Undefined. I thought about it for a second. Thank you. So in this case, it's pretty easy to see that x cannot be 0. Okay, it can be anything else other than 0. Obviously here, if I put a 0 there, it would make this fraction 0. Or if we put 0 there, it would make that fraction 0. So let's take a look at this one. Any ideas? Can we have 0 in this case? Yeah, we can. It wouldn't be a problem because even though we have that 0, we're subtracting or we are adding to it, which makes it something that is non-zero. However, what x cannot be is going to be a 2 or negative 2. Because if we take 2 or negative 2 and we square them here, you're going to get a positive 4. 4 minus 4 does end up being 0. And you just can't have that. Okay, questions there? All right, solve rational equations. So, easiest way to solve most rational equations is to multiply all terms by the equation by the least common denominator. Let me go ahead and just show you what I'm talking about. So here we have this equation, or this rational equation, and we're trying to solve it for x, right? Taking a look at that, what's the common denominator? 20x, right? Yay, 20x. So what I'm going to do is multiply every one of these terms by 20x. 20x there, 20x there, 20x there. Okay? So everything gets multiplied, right? Whatever you do one side, you got to do the other. And this is why. We don't want these denominators there. So what's going to happen here is that this 20 is going to make one with that 20, and you're going to get negative 3x. This x will make one with that x, and you'll get positive 20. This x will make one with this x. 4 goes into 25 times, and you're going to equal 25. So now you've created a linear equation. What's up, boss? Oh, there, yeah, I wrote it wrong. Thank you. Good looking out. Right here. This should not be 20. That should be 2 times 20, which is 40. Now, that's something very doable, right? That's something you've seen before, and you can do that. So now you don't have to worry about all the fractions. What we've done is we've created an equivalent expression, or an equivalent equation. And then you can go ahead and solve that. So the value of x would have to be 5. questions there? Okay. Now in this case, we actually have equations. And we actually found an answer, or a supposed answer. You gotta make sure that you check it. So, you guys know how to check stuff, right? Plug it back in. What should happen at the end? Yeah, both sides should equal each other. So, once we go through, we should get the same expression. If that's a true expression, or a true equation, then your solution is correct. If it's not true at the end, then you did something wrong. Or maybe it has no solution. Okay? Moving on. Yay. How about here? You guys want to try that? You were just playing Joseph too. Okay. Berto, come help us out. Come help us out with this one.
Yeah, I'm lost too. I sat this one out. I was thinking about the story you told us about motor skills. Yeah, we were talking about
So if you take a look at the denominator, the common denominator is going to be x minus 1, x plus 1, right? That's because of the last value there, the x squared minus 1. That's the difference of squares. So everything's going to get multiplied by x minus 1, x plus 1. So when we look at the first term, the x plus 1s are going to cancel out, and you're going to get 3 times x minus 1 is equal to 1 times x plus 1, and the whole denominator goes away there, and you got this. And that's what you're going to solve. Which one? No, no x's. Because the denominator will factor into x plus 1, x minus 1. So it's both the same. That's just 1. So you're just left with the minus 2 at the end. Okay? You guys can finish that from there?
Why did I do that? Let me check it. Yeah.
Okay, I'll finish it up. Using the distributive property, you're going to get 3x minus 3. That is equal to x plus 1 minus 2. 3x minus 3 is equal to x minus 1. If you take x from both sides, you're going to get 2x. Add 3 to both sides, you're going to get 2. So it looks like x equals 1. Okay, so let's plug it in and check. So 3 halves is equal to,
Where did the 2 go?
say it again?
The 2. Oh, it turned into -1. Never mind.
Cool. So that's 1 over 0 minus 2 over 0. So does that work? Nope. So this has this looks like this has no solution. You live in Coolidge?
What?
You live in Coolidge?
No, I live in Arizona City. It's like far.
Coolidge is not that far. Okay, cool. Proposed solution. Since the proposed solution is not in the domain, it cannot be an actual solution. Supplementary equation shows y, So you have the empty set. Okay, try that.
So did you go on?
Okay, so from there you guys got to grab the common denominator. What's it gonna be? I don't know. Was it x plus 3, x minus 2, x plus 2? Yeah, the denominator would be x plus 3, x minus 2, and x plus 2.
Multiply every single one by
Huh?
multiply every single one by that.
Yeah.
Oh my.
What you can do, just leave it on. What you don't really have to do. Look, you're making it sound like it's a terrible thing. You found the denominator, which wasn't that tough, right? So all you need to do now is say, okay, I've got the 4. Look at that. What's already there? The x plus 3 and the x minus 2, right? So it needs the x plus 2. It's just like what we did before, except it's on a bigger scale. Okay, looking at the next one, there's a minus 1 there. Those were there, so it needs the x plus 3. Okay, last part of it. It equals 2 times, let's see, the 2 and the 3 were there, it needs the x minus 2. So there's the equivalent equation that you need to solve. It's just like what we did last time, except now it's an equation. We're multiplying everything by the same value. Should be good to go. Wow.
I know what it is. She needs money. 200 to go and start Thomas Road. No. Did I tell you about that? Yeah. You didn't schedule me with him. When I told the other manager. Oh my god, that actually happened. Yeah, she's like crazy. I'm sick. Oh no. She what? Oh, oh. She what? What? Hey, how did you know that? I feel like you're the only person who did know that.
Yeah. So I was like, wait, is there down here? Like, I'm so confused. I don't know. She has like certified car. But she goes places. They have certified car. I guess so. I was like,
So did I.
what? She seems so innocent. Like, when I talk to her, I'm like, she's weird too.
She seems so innocent.
Like, she's just
Oh my
like,
god, she's weird.
she just like, there's a problem. That's why I would never came.
I'm so dead the way she's speaking. Oh my god.
What am I doing that's gonna
Like, do you prefer to get a certified car? Like, it's so good.
Somebody come up with a solution?
Yes. I'm doing it.
A possible solution?
What else? Is there one?
I haven't done it yet.
I thought she did just that.
No, sir. I still don't know.
Saturday, to the barber, and then has plans with she does look like, and that was the first time like I was seeing her. I was like shaking on this.
Okay, my
Yeah, that's what I got.
You got -9?
I didn't get that.
No?
why is she just so confused?
Yeah, I'm gonna do it the long way.
What? I'm.
This whole thing confused me.
Where did I confuse you?
I don't even know. Like,
You know something. You can't say that at all.
Yeah, whiteout.
We've already done some of it. No, I'm not
oh
trusted
wait,
with
do the
whiteout.
long way real quick.
You don't trust me with whiteout?
I'm not trusted with whiteout.
You're not trusted?
Yeah.
Why?
Because I want to white everything out.
Can you do the one real quick? Because I got 3x plus.
Hold on, let me look. I don't want to leave her behind.
Just show me that part.
This part right here,
Yes.
how we got this?
Yes.
Do you see how we got this?
Yeah.
Do you see how we got the denominator?
Yeah. Okay, never mind. That was the
See, you do get it. All right, so
Oh, that's right.
you ready, Peyton?
No, I got it.
All right, that's what I'm talking about. Hot. Huh? Well, this is 8x plus 8, right?
4x.
Ah, JK. Smiley face, LOL. That's 4x plus 8, right? That's going to be minus x minus 3. I love it. You guys are so good. What's up?
How do you pick which one?
Well, right now what we need to do is we need to check if it's going to work, right? So, if I plug 9 into any one of those, am I going to get a 0 out of that? Any one of those? Not really, right? So, that's my solution. Because I know that the denominator, the only thing that in the denominator cannot be is a negative 3, a 2, or a negative 2. Is that any one of those three? Then we're good.
I'm confused on how you get three. Those three. Like,
I got these three?
yeah, how you take those three.
Okay, so I want you to look at these as 3 different items. That's why I color coded them. Okay? Let's start with the red. In our denominator, we're going to need x plus 3, right? Do any one of those other two have x plus 3? The last one does, right? But it doesn't have more than one of them. No, so I just wrote one of them over there. Then I'm going to take a look at x minus 2. Do either one of the other twos have an x minus 2? Does the other one have more than one? So I just write 1 over there. Okay? This has an x plus 2 in it, because we already took care of that one, right? That one over there has an x plus 2. Does it have more than 1? So I write my 1 over there. And that's it.
And then how do you pick what's the one it doesn't have?
Well, yeah, because what's happening is I'm technically multiplying the whole thing by this, right? So it's like distributive property. So what would happen is, if I multiply this to this, x plus 3 and x plus 3 would become 1, x minus 2 and x minus 2 would become 1, and you're left with the one that it didn't have in the denominator. Cool? Thank you. Holy smokes. That's a lot of work.
Oh, I thought that was
No, it is. That's what they're doing. That's what they did all that. That's too much for me.
Why is all theirs like way more?
Well, they like to go like every little detail, but you guys are smart enough to know some of those things. I can just skip them. Try this. I'll help you guys out. This is x plus 3 and x minus 1.
He's been doing it all the time.
But
I'm worried about this semester.
and y out.
Oh, shoot.
All right, so let's do this. Okay. This is just the red part. I just factored it. Okay. The whole thing, I'm multiplying by that denominator of x plus 3, x minus 1. Because that's the common denominator, right? So if I multiply it to this one here, well, the x plus 3 and the x plus 3 would become 1, wouldn't it? So I would be left with 2 times x minus 1. Okay, that's the first part. On the next one, I've got minus 1. The minus 1, x minus 1 with the x minus 1 over there would also make 1, right? This and that. So I'd end up with negative 1 times the x plus 3 equals, now when I get to the end, the x plus 3 and the x plus 3 would make 1, but so would the x minus 1. So I would just be left with the numerator of negative x squared minus 3x. Okay? Questions? Anybody? Stop. I did. Oh, can I factor this? Oh yeah, once I get there I can do that. But I think what I'm going to do is try to combine it all first before I do any, because you're thinking of factoring a common factor. But my suggestion is let's make it all one polynomial first, and then let's see what we can do, okay? So here's what I'm suggesting. 2x minus x would leave me with x. Negative 2 minus 3 would leave me with negative 5, right? That equals negative x squared minus 3x. If I bring those to the other side, I'd end up with x squared plus 4x minus 5 is equal to 0, and that's what I would factor. Which is what? X plus 5, x minus 1. So possible solutions in this case are not just one, but two of them. My possible solutions are going to be negative 5 and 1. Possible. Now what I would do is take a look at that, what can be in the denominator. Let's see here, what's in the not denominator, what am I trying to say? Domain. You can't have a negative 3 and you can't have a 1, right? Are any of these two solutions not supposed to be in the denominator? The 1, right? So my only possible solution would be x equals negative 5. Because the other one would make one of the fractions undefined. Right. And all I really had to do was say, okay, looking here, I can't have those two in the denominator, right? I can't. Well, where did it go? Is this even the one?
No.
More?
Go back.
There it is. Okay. Those two can't be my denominator. I'm saying that one of the possible solutions is 1, but it can't be x. See that? X, what should I say? How do I write this? X cannot equal negative 3 or 1. I'm saying 1 is, so I'm saying, sorry dude, you can't be. So the only one that's legit would be negative 5. Yeah? Old Spice. Are we good here? Any questions? Questions? You're good? All right, cool. Moving on. So, there's what we're saying. Possible solutions are 5 or negative 1. Continue, because 1 is not in the domain, then it's not a solution. So you check the 5. And we're good to go. All right, cool. Recognizing the graph of a rational function. Recognizing the graph of a rational function. Okay. Before I get into those, and I don't know if it's an example, I haven't seen it yet, I want to show you the most basic rational function there is. It's the parent function for f of x is equal to 1 over x. Okay? Have you guys seen this function before? Yeah? It looks like this.
Oh, yeah, we have.
Did I do that right?
We did that earlier.
Right? Okay. However, here's a question here. Do you see how this gets closer there to this line? Never touches it. Does the same thing there. So it's getting really, really close to here. It's getting really close to the, what is that, y-axis? It's getting really, really close to the y-axis, but it never touches it. Do you guys remember the word for that? Starts with an ass, ends with an asymptote. Yeah. We call that an asymptote. So the function is getting really, really close to that. Infinitely close. Infinitesimally close. But it never crosses it. It never touches it. Okay? And the reason for that is because what would the value of x be at this line? What would it be? It would be 0, right? And can we put 0 in the denominator of this fraction? No, because that would make it undefined. Does that make sense? Now, if you had me for the other classes for Algebra 1, second year algebra, we talked about how we take functions and we move them up and down, left to right, and we change how sloping they are, right? Move them left to right, up and down. So if I had an equation, thank you, sir. Hey, check. South face. So I could take this function, f of x, and say, hey, now it's 1 divided by x plus 2. What's
It has a room number. Do I go?
Yeah, go ahead and go to that room real quick.
Are you serious?
Yeah, go.
Just open it.
What time is it?
I think
Go now. Go to that room.
Are you sure?
Yeah, I'm dead serious.
Live a little.
Where's that 106? Where's that 106, guys?
Okay, you're in the room.
Yeah.
Oh my gosh, are you serious? I should have let you walk out.
Make her go searching for it. I can't find it. The limit does not exist.
We all said it to each one of them. Was like, it's here.
She turned red. I'm sorry, Faye.
No, I'm just.
Back up here real quick, because this could get really hard if you don't know what we're talking about, and it can be really easy if you pay attention. So, here's what's happening. I've taken all the value of x, and I've shifted them. I've shifted them 2 units to the left. I've shifted them 2 units to the left. So, the asymptote that was here, here, where x equals 0, the asymptote is now here at x equals -2. Okay? And then my graph is going to look like that. Okay? So the point of what I'm doing here is simply saying, wherever the denominator equals 0, what that's going to produce for you is something called an asymptote. Okay? It means it's going to get closer and closer to that, but it's never going to cross it. So stuff's going to get really fun right about here.
What did I just do?
I don't know. What did you do? Okay, so, bop, bop, bop.
I need water.
All right, this is important, some vocab there. A function defined by a quotient of polynomials is a rational function. We already talked about that. Because one or more values of x included from the domain for many rational functions, their graphs are often discontinuous. That is that there will be one break or more breaks in the graph. A vertical line with an equation x equals a is called the vertical asymptote of the graph function. Okay, you guys remember how to graph vertical lines, right? So they're written in the form of x equals whatever that asymptote's at. So in our case, the first one, when we did, when I did this one here, the asymptote is at x equals 0. Over on the blue one, what's the equation to the asymptote?
I thought you said that.
Okay, x equals -2. What's that? Okay, so one asymptote over here is x equals 0. Over there, the asymptote equation is x equals -2. You're going to need to know how to write those equations, okay? Sorry to talk really fast because I'm getting excited. Is the bell's gonna ring? No! Okay, we already did this one, and I guess we'll pick this up tomorrow.
Mr. Manager, my 7.1 is in it.
I don't know. Did you send me an email?
Yeah, like a week ago.
Oh, then I have that.